The video begins with a breathtaking cinematic reveal of a massive offshore oil platform rising above the ocean at sunrise. Thousands of steel pipes glow in golden light as helicopters circled overhead and waves crash against colossal pillars. The camera dives toward the drilling tower in a smooth, high-speed motion while bold text fades in, "Millions of barrels extracted daily." Immediately after, we cut into a high-tech close-up of crude oil rushing through transparent industrial pipelines. Digital overlays appear in real time, showing pressure, flow rate, and routing information. Robotic valves open automatically as the system directs crude toward the main refining complex. The tone is set instantly. This is the scale, power, and precision behind the modern oil industry. A sweeping drone shot transitions to vast desert oil fields dotted with pump jacks moving in perfect rhythm. Each metallic arm pulls crude from deep underground reservoirs with mechanical consistency. A modern hydraulic drilling system rotates rapidly, boring into deep rock layers with extreme precision. Inside a state-of-the-art control room, engineers monitor drilling progress using holographic displays that visualize pressure, depth, and geological activity. Automated rigs perform tasks that once required dozens of workers, while robotic cranes lower massive drill pipes into the ground. Cutaway visuals reveal underground oil formations mapped by real-time seismic scanners. High-pressure mud pumps circulate drilling fluids through the system, regulating temperature and removing debris as drilling continues. Workers in protective suits inspect robotic components, ensuring the machines operate flawlessly in the harsh conditions. A drone sweeps past pump jacks silhouetted against a fiery sunset, capturing the immense scale of oil extraction. High-speed shots show crude rising through steel well casings before moving into automated manifolds that regulate flow across dozens of wells simultaneously. Insulated pipelines stretch across the landscape, transporting crude to central processing stations, where separators remove water, gas, and impurities. From there, we transition into the transportation phase. Wide drone shots reveal pipeline networks winding through deserts, forests, and mountains, connecting remote oil fields to industrial hubs. An internal pipe camera captures crude flowing at high velocity. Pumping stations boost pressure every few kilometers, ensuring a constant, uninterrupted stream of oil across long distances. Huge storage tanks fill with millions of barrels, their massive domes towering over workers and vehicles. Tanker trucks line up with robotic systems clamping the lids shut for transport. At coastal terminals, colossal supertankers dock beside loading arms and high-pressure hoses. Control towers oversee every movement using holographic dashboards. Waves crash against the ship as millions of barrels are pumped on board. Satellite imagery shows global shipping routes stretching across continents. Tugboats guide the fully loaded tanker into open waters. Meanwhile, trained tank cars carry crude across mountain tunnels, while pipelines deliver it directly into a refinery complex, a sprawling industrial city filled with smokestacks, towers, and endless pipe networks. Now begins the most high-tech part of the journey: refining. An aerial reveal exposes a refinery covering kilometers of land. Crude oil enters the primary distillation column, where massive furnaces heated to extreme temperatures. Inside the tower, vapor rises and separates into gasoline, diesel, jet fuel, and LPG. Robotic arms maintain furnace components, ensuring constant performance. Technicians analyze samples using laser spectrometers, checking molecular purity. 3D molecular animations illustrate how hydrocarbons are broken and restructured. Catalytic cracking chambers glow red-hot as they convert heavier molecules into lighter, more valuable fuels. Hydrocracking units further process heavy hydrocarbons into high-performance gasoline and diesel. Steam reformers generate hydrogen used in essential refining reactions. Huge desulfurization reactors remove sulfur and other impurities, and computerized monitors track sulfur levels in real time. Throughout the refinery, networks of pipes glow with heat signatures captured by infrared cameras. At night, the refinery resembles a glowing, futuristic metropolis. Thousands of lights, steam columns rising into the dark sky, and machinery humming non-stop. High-pressure pumps circulate refined products through enormous heat exchangers. Gasoline vapor condenses into liquid through cooling towers, flowing into storage spheres filled with liquefied petroleum gas. Drones inspect pipelines while robotic leak detectors patrol the ground automatically. Close-up shots show gasoline dripping into precision purity analyzers.
The concentration levels are fluctuating more than expected in the blue spectrum.
Yes, I see that. Let's run the sequence again on the next batch.
Keep the altitude steady. I want a closer look at that gasket.
Holding position now. The thermal scan looks clear.
The eastern pipeline is showing a slight pressure drop.
Let's normalize the flow rate immediately.
Done. The system is back in balance. Reroute the hydroflow to auxiliary immediately. We have an override in Sector 4.
Confirmed. Executing Sequence B now.
The pressure drop at node 4 is still critical.
If we reroute the primary conduit, we might stabilize the flow before the turbine.
Everything appears to be in order. Yes, the batch is approved.
From refinery to consumers.
refined for millions.